these three products, the 80 amp circuit breaker, the 200 amp circuit breaker, and the 300, give me a second, and the 300 amp circuit breaker, they perform identical. They break exactly 4 to 5 seconds after you apply 192 amps to them. We don't have a way to apply more precise amperage to them, but the point is, at 192 amps, all three of them break after about 4 seconds, 4 to 5 seconds. What does that mean? That literally means that these are the same products with just different labels on them. That is unconscionable. It's literally a crime. This is a safety product. So if I put a 300 amp fuse or a circuit breaker on my circuit and it pops too early, okay, well, that's annoying, but that's not a big deal unless this is like a critical thing. Even this one, it's like, okay, it pops at 192 amps, close enough to 200. Maybe it's okay. But this one, this is an 80 amp circuit breaker. If you actually had an 80 amp circuit connected to this 80 amp circuit breaker and you start pumping 192 amps through it, you're going to have a fire. You're going to have a fire. This didn't break at 100 amps. It didn't break at 120 amps. It didn't break at 160 amps. It took 182, 192 amps to break it. And this is a 80 amp circuit. These people should go to jail. This is a crime. Hey everyone, so today I'm actually kind of a bit upset. I'm going to show you our experience with, let me show you here, these kinds of circuit breakers. We installed them in our van build over here and over here to run some of our higher power equipment. So I can guide you right here. This circuit breaker right here dives to the other side of the van and handles all of our DC power. And this circuit breaker right here, that one was supposed to power our inverter, hence it's 300 amps. Though to be perfectly honest, as soon as I got it in the mail, I should have been immediately suspicious that this kind of bolt, this kind of nut, I don't think can handle 300 amps. I was deluding myself thinking that maybe the bolt underneath it is tin-plated copper or something like that, and as a result it can carry that much current because copper would be able to carry that much current. But no, it's just steel, and it doesn't look like it can carry that much current at all. And this is sheer lie. So this is going to be posted under all of the listings on Amazon for these breakers, because this rating right here, 300 amps, is a complete and utter lie, and I will demonstrate it to you right now. So what I have right here is I have a Renogy amp meter or battery monitor thingy hooked up right here, and right here you can see the amps that we're pulling from the battery. So negative roughly 1 amp, 0.7. That's because the inverter is on. So if I turn off the inverter, I just turned off the inverter, you'll see the amperage goes down to you know, basically 0. Now let's go ahead and turn the inverter back on. It pulls up, and you can see that now the current draw is about 700 milliamps. That's just the standby current of the inverter. Now to apply some load, well, before I apply load, I'm going to use this temperature sensor right here. And I'm going to sense the temperature of the meter. I'm sorry, I'm going to sense the temperature of the circuit breaker. So you can see roughly 60 degrees. So pretty cold. It's been sitting overnight. So now I'm going to turn on the first, and I have 2 space heaters over here connected to the inverter. So as soon as I turn on the space heaters, you will see some amperage. So let's just start by turning on the fan. So I kicked on the fan. That's without the heater. And as you can see, we're drawing 2 amps. Now I turned on the heater, and we're drawing 100 amps. Right? Now at 100 amps, let's see what temperature is. And as you can see, the temperature of this unit climbs quickly and instantaneously. So this is handling tremendous amounts of heat for us, even at 100 amps. Now, let's go ahead and put it to the next setting, which is 120 amps. And then let's turn on the second heater. We have 200 amps. Now let's just wait. So 192 amps. And you didn't see me do anything at all. That's my inverter saying that it's dead. There, at 200 amps, you saw it was powering 200 amps for just a few seconds. And it popped. Not even 200, 192 amps. So let's try it again. We'll turn off the inverter. It's too hot to even close right now, so we have to wait until it cools down. So let's wait until it cools down and then try it again. There. So it just locked in. Let's turn on the inverter to 0 amps. There you go. 189 amps, 194 amps, 194 amps, 193 amps, and I'm sure this is about to pop. Will it start melting? Let's see. Oh, and there it is. I had it covered up with my hand, unfortunately, but you know, here's the temperature. It's already at 67. As you can see, it's climbing quickly. So if you try to boil a pot of tea or something, you'll be in for a surprise. Anyways, I'm gonna go ahead and test the 200 amp and write down when it pops. And I also have some 80 amp breakers. I think these are good for about 80 amps to 100 amps in terms of the connectors, but past that, I think they're bad things. Okay, so this one popped again. So I'm gonna just demonstrate it for the third time. I'm gonna make sure that it's not too hot. So there you go. There you can see how much hotter the unit has gotten just from these tests, right? 80, and we started at 60. Yeah, so 66. So I'm gonna go ahead and close this unit again, and I just wanna demonstrate it to you guys on camera so you see that there is no trickery. I'm gonna go ahead and zoom out, I guess, so you can see that I'm not doing anything to these things, because I know the manufacturer of these things is going to accuse me of that. So it's already getting very crusty indeed. So I'm gonna go ahead and turn on the thing, and then I'm gonna zoom out like this, so you'll see me not touching it at all. You'll see the amperage at the top is at 189, 194 right now. And we'll see how many seconds it lasts like this. There you go. So barely less than 20 seconds. Less than 20 seconds. And again, this thing was 194 amps. 194 amps on a 300 amp circuit breaker that's supposed to handle up to 500 amps according to the manufacturer. So you do your own judgment there. And just to show you, we have 700 amps worth of battery power connected, and well, that stuff doesn't matter, I guess. So, and this is our system. What I'm going to do is I'm going to test off camera this breaker, as well as the 80 amp version of this breaker, and I will be posting this video underneath those products at Amazon, because this is ridiculous, and I'll be listing what the 200 actually does, what the 300 actually does, which apparently is roughly 180, 190 amps, and even at 190 amps, this thing will pop after 30 seconds. So this is not even a 190 amp fuse circuit breaker. This is maybe like a 150 amp circuit breaker, if that. So like basically divide this number that they write by half, essentially, at least for this one. And then maybe, so like, let's say you have a circuit that on average would draw like 75 amps. Like this is probably good for my air conditioner. That air conditioner right there draws 75 amps DC and 12 volts. So maybe this would be good enough for that. And that's, I think, what I'm going to use this for on that other side. But 300 amps? I mean, are you fucking kidding me? Actually, just for shits and giggles, let's go ahead and put it in right there. Let me just turn this up to high. So that's 260 amps. That's what, yeah, you see right here, it's going 261 amps. Boom. Sorry, I couldn't capture it, but less than 5 seconds, it's capable of maintaining 260 amps, which again is 40 amps below its advertised rating. Anyways, I hope this says it all. I will be posting results for this guy, those guys on the other side, and these switches right here. And for these switches, obviously the switches are not going to pop or anything like that. What I intend to do is I intend to measure a voltage drop across the terminals at roughly 200 amp load. What this will tell me is which one of these 3 switches has the best connectivity, which one can carry the amperage the most, because the one that has the lowest amp draw has the best performance. Oh, by the way, I measured voltage drop of this guy at 200 amps, and at 200 amps, this basically becomes a 55 watt heater. So 55 watt heater sitting in your electrical closet. There, I'll turn off the thing. All right. I will be back with the rest of the results. Okay, and we're back. And I installed the 200 amp breaker in place of the 300 amp breaker. Let me grab the 300 amp breaker. Here it is. So this one is out. This one is in. Let's go ahead and kick on the inverter. Let me go ahead and check the 70 degrees. It's gotten a little bit warmer because it's just a little bit later on in the day right now. And we can see right now, by the way, I removed this guy from its frame so it doesn't put so much strain on the cable. But anyways, so right there we are at 0.7 amps. Let me hang it such that you guys can see it. 0.7 amps. Now let's go ahead and turn on our fan. Now there we are pulling 2 amps. No problems, of course. Let's go straight to 100 amps. So this is 100 amps right there. Yuki's gonna hold it for us. There you go. And let's see how our breaker is doing. Let's see if it's getting hot. It's not getting particularly hot, which is actually impressive. In terms of, it's already up by a few degrees though. Okay, let's go ahead and go to 120 amps. So 120 amps. It's holding straight. Is it getting hot? No, actually, interestingly, this is performing better. Well, about the same as the 300 amp. Now, what are the chances? Let's go. Okay, that's maxed out. That's 190 amps. And it's holding at 190 amps. Okay, let's see if it works as a breaker. 250 amps. 250 amps. And there it popped.
We reached all the way to 260.
That's Yuki in the background. So we went all the way to 260 before this thing popped. So essentially, there is no difference between these two parts. This one pops at 180. This one, well, let's retest this at 180 and see how long it takes it to pop at 180.
Should we bring it
But
on?
basically, this one pops at 180.
Yeah, but should we time it? How long we suspect it's the same product. It's the
Yeah,
same
I think
kernel.
I think it's literally the same product with just different markings on the casing.
Yeah.
That's
We should start a timer.
That's
to see.
amazing. Let's check it out. So let's see when this one cools down. As soon as this one cools down, we'll be able to run the test
Oh,
again.
can you measure the temperature? What temperature that we reach before it went off?
Give me a moment. Let's see. Oh wait, say hi.
Hello.
There's Yuki in the background. All right. Let's see. 80, 82-ish
And so we went up 10 degrees.
on the output side. Yeah. All right, so it popped it back in. So let's see. There it is. Let's turn off our heaters.
Yeah.
So now what we're gonna do, and we'll just time it based on video,
Okay.
is we'll see how many seconds
We can
it will
also start-
hold at.
Start. I'll bring my phone. I'll just go fetch my phone.
No. We'll see how long it holds at 120, at 180 amps.
Okay.
So can you set it up for us? So that's gonna be
I'm gonna go around.
124 amps, and we're gonna turn the other one to the first. That's 192. So we're gonna hold this at 192 and see how long it takes before this one pops. So the previous one, the 300 amp one, popped in about 3 seconds or so.
I thought it was more like
4 seconds. Okay, so basically identical. These two products, the 300 amp and the 200 amp, are identical. They have identical characteristics in terms of how much load they can handle. Okay, let's try the next one up. Is the 80 amp. Let's see if it's literally the same product. And we're back. We are now with the 80 amp breaker over here. So let's see if the 80 amp breaker proves to be any different than the 200 amp breaker, which proved to be identical to the 300 amp breaker. Anyways, let's see. Let's start with low. So 57 amps. Oh, I forgot to do the test. Let's see. 75. 73 rather degrees. And that's 57 amps that we're pulling. Seems to be handling it just fine. Okay. Now I'm gonna go turn this one off. So now we had back to like 1 amp or so. And then I'm gonna turn this one on. That's gonna go straight to, oh, this one. That's straight to 104 amps. And it should be popping. If you actually needed an 80 amp breaker, that should be popping by now. Because that's a 109 amps. It's 109 amps.
your electronics might be dead by now.
You know, you would have a fire by now. Okay, I'm gonna go to full 121 amps, 50% over its capacity.
Oh no.
This is still going. This is still going. Okay,
Starting the second heater.
starting the second heater. So there, 200 amps, and it blew. We're gonna run this test
What
again.
temperature are we hitting on the terminals?
In terminals, let's see. 80.
So just like the previous one.
Just like the previous one. So in actuality, this popped at the same level as the 300. This is incredibly irresponsible. These people should go to jail. The people who sell these products should go to jail. This is incredibly, this one and this guy are the same product. We'll run it again. But this time around, here, let me turn off the inverter. I'm going to put this off. Okay. So now we're going to go ahead and start the inverter. We beeped up. Right? And then I'm going to turn this guy and this guy. So we're pulling 200 amps, 192 amps. And look at this fucker. There. Same 5 seconds. Same 5 seconds you got out of this, and same 5 seconds you got out of this. Look at this. These two products, one says 300 amps, the other one says 80 amps. They're the same product. This is literally criminal. We're going to file a case with Amazon if there is an opportunity to do so. And this is literally criminal. All right, that's it. Next up, we're going to test the switches, but that might be in a different video. But this video is going to be posted underneath every single one of these breakers, at least the ones that I bought, and I bought them in every single variation from several sellers. So I'm posting this video underneath all of them because I'm going to test the rest of them. And yeah, this is literally a crime. Like, people could die in a fire as a result of them sizing an 80 amp breaker exactly the same as they're sizing a 300 amp breaker.
And a 300.
This is just unconscionable. Anyways, that's it. So we just finished these tests, and the upshot of these tests, get in here, let's show them. These three products, the 80 amp circuit breaker, the 200 amp circuit breaker, and the 300, give me a second. In the 300 amp circuit breaker, they perform identical. They break exactly 4 to 5 seconds after you apply 192 amps to them. We don't have a way to apply more precise amperage to them, but the point is, at 192 amps, all three of them break after about 4 seconds, 4 to 5 seconds. What does that mean? That literally means that these are the same products with just different labels on them. That is unconscionable. It's literally a crime. This is a safety product. So if I put a 300 amp fuse or a circuit breaker on my circuit and it pops too early, okay, well, that's annoying, but that's not a big deal unless this is like a critical thing. Even this one, it's like, okay, it pops at 192 amps, close enough to 200. Maybe it's okay. But this one, this is an 80 amp circuit breaker. If you actually had an 80 amp circuit connected to this 80 amp circuit breaker and you start pumping 192 amps through it, you're going to have a fire. You're going to have a fire. This didn't break at 100 amps. It didn't break at 120 amps. It didn't break at 160 amps. It took 182, 192 amps to break it. And this is a 80 amp circuit. These people should go to jail. This is a crime. That's it.